Hello everybody, this is Mr. Longo here, and this video is going to introduce you to graphing sine and cosine waves. Now, the thing you need to know about a sine and cosine graph is the fact that they are periodic, also known as cyclic, which means that the dependent variable takes on the same value over and over again as the independent variable increases. So basically what that means is, as x goes on, y is going to continue to repeat itself. And that's because of the unit circle. It's circular, so also known as it's going to be a cyclic type of function. Now, when you stretch a circle going around the unit circle onto a linear graph, that's why it becomes periodic. You'll see as we go. So let's start off by talking about the general forms of the equation and what some of these variables, or shall we say letters, represent. So the same is y is equal to a times sine of b times x minus c plus d. Same thing with cosine. Now what do these mean? So we have a little bit of definition here. First of all, the periodic function, as we already talked about, the graph from one point to another point, and it starts to repeat. That is one cycle. So once it starts to repeat itself, you are going into a second cycle. A in both of the equations represents the amplitude. So that's the distance from the node line to the crest and the trough, which are your middle, highest, and lowest points. The frequency is how many cycles that occur in 2 pi. The standard cycle or period for sine and cosine is 2 pi. That's when you reach one full rotation of a circle. The period is how long it takes just for one cycle. A phase shift is just how far you shift the graph to the right or left, also known as a horizontal displacement. And a vertical shift is how far the graph is shifted up or down. And that is going to be with respect to the node line. So once we start talking about some of these graphs, it'll be a lot easier to understand. So let's just go check it out. Let's start with the unit circle. So if we have all of our coordinates from our unit circle, we have to remember that they go in terms of cosine comma sine. Remember, cosine is x, sine is y. So to make this a little bit easier to see, we will do this in color. So first we'll do the x. This is where x is equal to 1. This is where x is equal to 0. This is where x is a negative 1. And this is where x is 0 again. So now we're going to go do sine, which is y. So this is when y is 0. This is when y is 1. 0 again, down to a negative 1, and back. Now, of course, we have our square roots of 2 over 2 and square roots of 3 over 2 and 1/2 from the unit circle along the way. So whenever we are graphing, we have to remember that we start at 0, then we go to pi over 2, pi, 3 pi over 2, back to 2 pi. Of course, that's also going to be in terms of degrees as well. So this could be 0, pi over 2, pi, 3 pi over 2, and 2 pi. Again, if we were to do this in degrees, it would be 0, 90, 180, 270, and 360. So it's going to be the same. Now we have a standard amplitude of 1. So we're going to go up to 1 and down to a negative 1. Now we are going to do cosine first, because cosine is x. So if we were to go at, I'm talking 0, let's talk about 0 degrees on the unit circle. So we have 0 degrees on the unit circle, pi over 2, pi, 3 pi over 2, and we finish at 2 pi, which is one complete cycle. If we were talking about cosine, what is the cosine of 0? It's 1. So cosine starts up high. What is the cosine of pi over 2? 0. So we're here. What is the cosine of pi? It would be a negative 1. So see, that's how we're turning a circle into a stretched out horizontal graph. Cosine of 3 pi over 2. is back to 0, and then we get back to 2 pi, and we have just completed one cycle of a cosine graph, because all we were doing is plotting the value of cosine of x from the unit circle onto a graph. Now, as this were to continue, it would start to repeat itself. That's why that is called one cycle, because it's one starts to where it starts to repeat. That is one cycle. Now, if we were to do this with sine the exact same way, what's the sine of 0? It's 0. What is the sine of pi over 2? We are up to 1. What is the sine of pi? Back to 0. Sine of 3 pi over 2 is at -1. Sine of 2 pi, back at 0. So we're going to have a very similar shape. All of our sine and cosine waves are going to look like this. And then it would continue past that as it would go beyond the first cycle. Okay, so again, this video is to show you all of the different parts of your standard sine and cosine waves. The video after this will get into a lot more detail. So for the standard ones, as we mentioned, the amplitude is going to be 1. The period for sine and cosine is always 2 pi. And there is none as our answer for the vertical and phase shifts, because it did not move anywhere. That's where the C and the D come into play. So now that we know what a basic function looks like, we are going to go talk about some other modifications to the function. So 1 and 2, the only thing we're going to do in this video is talk about the different types of shifts or transformations. The next video will actually graph them. So, in number 1, we'll go through this one together, and then you guys can do the next one on your own. Amplitude, remember, is A. Now, amplitude is the number that comes in front. Our amplitude is 2. The negative is not an amplitude. It's basically telling us again, as it always has, reflection over the x-axis. Okay? Now, frequency. The frequency is our B value, so our frequency is 4. Our phase shift. Our phase shift is our C value, but we have to remember the horizontal shifts are always opposite of what you would expect. So the fact that this is plus 30 tells us that we are going to shift left 30 degrees. And our vertical displacement would be up 7. So whenever we're talking about a phase shift or a vertical displacement or a vertical shift, make sure that we are talking in terms of up, down, left, and right. Don't say -30, don't say +30, don't say -7 or say left 30, right 30, up 7, down 7. Make sure you give a direction. Okay? Now, we need to talk about period. The period of one cycle. The period is always found by doing 2 pi, your standard sine or cosine length of a cycle, divided by how many different times a cycle occurs in 2 pi, which is 4. So 2 pi divided by 4 simplifies to pi over 2. So that means the period of one cycle is just pi over 2. So every pi over 2, this cycle is going to repeat itself. So if we were to go back just temporarily to the example we had up here, this means that it will repeat itself, so go up, down, and back up by the time we get to pi over 2. And it would do that every pi over 2, which is why we would have 1, 2, 3, 4 different cycles in 2 pi. That's what frequency is. So it would happen 4 times in one full 2 pi, which means one cycle would just be 2 pi divided by 4. Now, the equation of our node line is our vertical displacement. So if we were to look at this graph right here, we could draw in a few lines. The top line would be known as our crest. The bottom line is known as our trough. And the line where we use our center reference, that's our node line. So the equation of our node line would just be y is equal to 7 for this one, because that's our vertical shift. Our maximum value would be with our amplitude, so it would be 2 above 7, because if our amplitude is 2, that's 2 above 7, that's going to give us a maximum y value of 9. And 2 below 7 would give us a minimum y value of 5. Okay, because remember, amplitude is how far above or below the node line we are. Okay, so now that we just went over one of those, I would like you to pause the video and you can try this next one on your own. And as soon as you're ready, click play, and we will see if you were able to get the whole thing on your own. Give it a shot. So amplitude is A, so you should have said 4. The frequency is B, so you should have said 1/2. That means only half of a regular sine or cosine wave, in this cosine, is going to occur in 2 pi. So this is going to take 4 pi for one cycle to occur. We'll explain that in just a second. Your phase shift is what we get from the inside. That is pi to the right. And our vertical displacement is 1 down. Now the period of one cycle, as I already mentioned in the previous example, the way we find our period is 2 pi divided by b. So if our b value is 1/2, that's 2 pi divided by 1/2, which we know when we divide by a fraction, we multiply by the reciprocal, so we have 4 pi. So it takes 4 pi before this starts to repeat itself. The equation of our node line is y is equal to a -1, because that's our vertical displacement. If our amplitude is 4, 4 above -1 means we have a maximum y value of 3, and 4 below -1 would give us a minimum y value of a -5. Okay, so that is the introduction to what we are going to be graphing. Now in the next video we are actually going to go graph it, and some of this might make a little bit more sense once you see that. Okay, so anyway, this is Longo and I'm out. See you, bye.